So we've done some work on arithmetic sequences, determining the nth term and the formula for calculating terms within the sequence, and how to find the a and the d when we look at the general format of it. What I'm going to do here is I'm going to present you with a couple of questions. I want you to pause the video, have a crack at them, and then come back and check your working against the working I'm going to present here. So here you go. First thing I want you to do is find the nth term for each of the arithmetic sequences given there. And then the second one is, I've told you the sixth term of a sequence and the eighth term. I want to know what the nth term is based on that. So pause the video and have a crack at both of those. So the first question, if I've given you the sequences below, what I want you to do is find the nth term for each of the arithmetic sequences. Now remember, the format for our nth term is un equals a plus n minus 1 times d. Now for these sequences we have to determine a and we have to determine d, which we call our common difference. Now a is always the first term, i.e. u1 is equal to a. So for this sequence here I start at 5, so u1, which is equal to a, is 5. I then have to look at my common difference, which is the difference between each term as I move up or down the sequence. Well, 5 to 8 is 3, 8 to 11 is 3, so I know then that my common difference, d, is equal to 3. Just look at the difference between consecutive terms within the sequence. So I would do 11 take away 8, I'd do 8 take away 5. That's where I'd get that from. So therefore, what I can then do is say, right, so I know then that un is equal to a, which is 5, plus my n minus 1 times my d, which is 3. And this is where we then do what we did before as well. Multiply out the bracket and simplify it all down. So that would then give me 5 plus 3n minus 3. So from that I can then say therefore for this first one, un is equal to 2 plus 3 times n. Second sequence here, I've got negative 1, 4 and 9, and it's the exact same sort of format. My a is given by the first term, so my u1, which is a, in this case, is negative 1. Now, I've never said you can't have negative numbers for the a or the d, so we have to bear that in mind as well. So then to get the d, I look at the common difference. So in this one, I look at 4, take away negative 1, which gives me 5, and I look at 9, take away 4, which also gives me 5. So what I can then say is, therefore, my common difference, d, is equal to 5. So I know both parts of the nth term of my sequence that I didn't know before, plug them in, simplify it, job done. So for this one, I say, right, so un equals negative 1 plus n minus 1 times d, which is 5 in this case. Multiply this out and simplify. So I get negative 1 plus 5n take away 5. So in this case, I can say, fine, un is equal to 5n minus 6. So there you go, formula for the nth term. This one here, it's the same drill and the same set of steps. First thing I have to calculate is my a. So I know that u1 is equal to a, which is the first term, which in this case is my 3. I then have to find the common difference. So I have to find the difference between terms. So in this case, I do 2.8, take away 3, and in this case, I get negative 0.2. I then look at the exact same thing. So 2.6, take away 2.8. Again, I get negative 0.2. So from that, I can say, fine, my d is equal to negative 0.2. We've never at any point said you can't have a negative common difference. So if the sequence is going down and decreasing each term. What I then do is just plug it all together, see what I get. So I know I've got un is equal to my a, which is 3, plus the n minus 1 times my d, which in this case is negative 0.2. Multiply this out, simplify it, and we're laughing. So we've got 3 take away 0.2n. I've then got minus 1 times minus 0.2. So I've then got plus 0.2. So from that, I can say my nth term, un, is given by 3.2 take away 0.2n. There you go. Job done. So that's how I can determine the nth term of any of my sequences. have to do the same thing. Find my a, which is the first term of the sequence, find the common difference, so the difference between un plus 1 and un plus 2 and un plus 1, and then plug it all together and simplify as much as we can. Don't leave it in this format here. Use this format to get it together at the start, but always aim to leave it like this. Second question I asked you was, if the sixth term of a sequence is 22 and the eighth term is 30, what is the nth term? So again, this goes back to using our general term, un equals a plus n minus 1 times d, and this is similar to the second example we looked at before. So we've got two terms, two set terms somewhere within the sequence. What we're able to do is find a system of equations because we've got two unknowns, solve them, get both the unknowns, and put it all back together. So my sixth term here, I know that n is equal to 6, and I know the whole thing is equal to 22. So what I can then say is fine. So for the sixth term, 22 is equal to a plus 6 minus 1 times d. So for this one here, I know 22 is equal to a plus 5d. Second term I'm given is the eighth term, which is given by 30. So from that, I know that 30 is equal to a plus n minus 1, so plus 8 take away 1 times d. So from that again I can say that 30 is equal to a plus 7d. So I've got two equations here, two unknowns, stick them together as a system of equations to solve them, and I can find my a and my d from that. So if I write this equation underneath it, so I've got 22 equals a plus 5d, and then again, treat it as simultaneous equations and solve it. 30 take away 22 is 8. I've got a take away, which is nothing. 7d take away 5d is equal to 2d. So 8 is 2d, so from that, I can say that d is equal to 4. Take this d and substitute it into either of these two equations to find whatever the a is. So let's go to this one here. I know that 22 is equal to a plus 5 times the d, so 5 4s, which are 20. So from that, it's quite easy to determine that a is 2. So I know the a and I know the d. I can plug it all together now and say fine. So un is equal to 2 plus the n minus 1 times the d, which is 4. And again, similar to before, multiply it out and simplify it as much as you possibly can. So that's 2 plus 4n, take away 4. So my nth term, un, always write that to start because you want them to know that it's the nth term you're getting. So un equals 2, take away 4, so it's negative 2 plus 4n. If you wrote it as un equals 4n minus 2, you'd be perfectly fine as well. Both variations are perfectly fine, unless they ask for it in the format a plus bn. Then it wouldn't matter either way. Alright, so we know how to use this general format for the terms of the nth term of a sequence. We have to be able to work with it, we have to be able to determine these terms, write them as simply as we can, and work with them beyond that. So make sure you can do that and have a look at the exercise in the textbook.